Jose, when it comes to Industry 4.0, what role can we expect generative AI to play?
Again, I think as we all know, we are in the middle of this fourth industrial revolution that we typically call Industry 4.0. This has been going around for almost a decade now. A lot of things has been done, but a lot of things to be done as we go forward as well, right? So, of course, the Industry 4.0 is all about digital technologies, bringing digital technology on the way we design products that are becoming more complex, how we manufacture these products in a manufacturing plant, and how do we service these products in the market as well, right? So it's a very broad scope, but I mean, it's a lot of things. AI has been an integral part of this whole transformation that the industry is happening in the industry. But now with the Gen AI, we believe we are now an inflection point, pretty much, right? We are now trying to move from models that were hard to develop, etc., to somehow models that are much easier to, first of all, faster to deploy, to implement and deploy, and they have the ability to scale. Scale is the name of the game going forward with Gen AI. Okay, so I have been working with clients around the globe in terms of the overall industrial sector. I cover pretty much from oil and gas, mining, industrial machinery, automotive, electronics, aerospace and defense, and there's a lot of excitement in the industries as well, right? And also even the governments. For example, in the US, you have the National Institute of Standards and Technology. They are creating an initiative, their sponsor initiative around Gen AI or AI in the manufacturing industry as well. So a lot of excitement that's happening on this one. But let me give you an example as well, right? If you go into a kind of a plant is where the rubber meets the road in manufacturing. That's where we're going to be getting from our designs into the physical product. Of course, the goal there is really to do this in a much more efficient way by leveraging the Gen AI technologies, reducing costs, improving the quality of the products that we produce, right? And reduce the variability in the process as well. So if you look at the manufacturing plants, we have one of a common metric that's being accepted globally. That's what we call overall equipment effectiveness. That look at the manufacturing plant in three main dimensions. One is the availability of the machinery to produce the goods, right? The second one is the quality. Are we producing quality products, right? Because if we're not, we have just the cost of reworking the products, or sometimes we have to scrap the materials that we're going to be using. And the third one is the performance, how well we are utilizing the plants, the throughput of the plant. So if you look at those three dimensions, we start with, let's say, the performance. It's extremely important that, if you look at the manufacturing plant, they have a very complex processes. Typically, this process, they are automated by the automation systems coming from the automation vendors. And for example, for a given process, the temperature might be very, very important to keep a temperature in a given range. And the systems would follow what we call a set point, how the system is going to maintain the temperature. However, many things can happen in the process itself. You have now a person in a plant looking at a number of screens and figure out what's going to happen in the process is going well or not. If something is wrong, the person has to take action to figure out how we're going to adjust the temperature in order to keep the system in good shape, more or less, right? So by doing this, a person can only do this, and they do this day in and day out, but they do this on a reactive way. Reactive ways, they have the screen, they have a problem, and they take actions to minimize the problem, right? But with Gen AI, the personnel can predict what's going to happen a few hours from now in this process and take proactive actions to avoid that situation to happen. In other words, only catching up, but being proactive. So Gen AI allows us to be proactive in monitoring those performance. Quality, another hot topic, of course. For example, the automotive industry or any other companies, right? In the aerospace and defense, you have a number of examples there how companies are struggling with the quality. So we have been using AI to focus to check the quality of the product itself, inspecting the quality for some time already. So IBM I think we are leading in applying AI in identifying quality problems there as well. And we're using machine learning, of course, to help us deal with this situation. But beyond, and we can do things 10 times more precise than typically a human can do. Just to give an idea, the power of AI on this one. However, right, detecting the problem is just part of the equation. How can we now help the quality engineer look at the situation of what's happening and identifying the root causes of the problem? For example, it could be a bad design that's creating a problem. Could be a vintage of a part. Let's say a bad connector coming from a given supplier. That can be a problem, or can be a specific operator that was not trained well, or could be even a procedure. How we can help the quality engineer do the forensic analysis in order to identify the root cause of the problem. That's the second part that you can do with GenAI whenever it comes to quality as well, right? And the last one is, again, the availability. Having the assets, the machinery in the factory ready to produce stuff is very, very important. Now we can predict with extremely high accuracy what's going to happen with the machine, the equipment, or if it's going to break or not, right?
Mhm.
And you can identify what will be the right time to do the repair, and also can guide the technician, the main technicians, to do the repair first time right. So minimize the mean time to repair. So as you can see, the applicability of GenAI in manufacturing is huge. And not only doing this, but doing this at scale and speed with higher accuracy as well. It's extremely important.
Now, I'm a big believer in Gen AI, but I suppose, like any new technology, there are some challenges associated. But any insight into some of the challenges companies face when bringing Gen AI into manufacturing?
Yes, I would say based on a lot of work with customers, we see a number of things from a challenging perspective. One is about the data. Data is the foundation of everything we're going to do in terms of dealing with digital technologies. Not only being able to access the data from different systems, but understanding the meaning of the data and the quality of the data. In the real-time data comes to either train the AI models or to feed the AI models to make a decision. Data is the first challenge. It's interesting. We did a study a couple of years ago looking at more than 2,000 manufacturing clients around the globe, and identified that they collect a lot of data, by the way, and 90% of the data is get unused, more or less. So using the data becomes very, very important. Put our arms around the data. Another interesting thing, especially in the manufacturing plants, that there are different data modalities that we're saying. One data modality is we're calling the time series data. It's data about pressure, speed, temperature, etc., that are coming from the processes, right? It's a completely different ball game dealing with this time series data compared to the large language models or that we're doing. It requires a different approach to deal with the time series data. The second one, talking about the quality one, we have been using, of course, AI for some time in training the models to detect what's a good and what's a bad part. But the training required thousands of pictures. We call this label data. This is a good, this is bad, the model can understand. But creating a foundation model for dealing with image data is completely ball game in the way you're doing. So now with just a few examples, the model can understand what is a good and what bad. So this would allow us to deploy these models much faster than before as well, right? So these are two examples. Another thing that we're doing that's very, very important. If you go to a manufacturing plant as well, they have their own terminology. We are talking about things like process instrumentation diagrams. We're talking about SCADA systems, DCSs, PLCs, failure mode and event analysis, or whatever. There's a lot of nomenclature, how we can pre-train a model in order to understand the nuances of a manufacturing plant. So we're doing a lot of work in training our models to understand the domain of manufacturing, right? Not only this, the size is not the key. Having a larger model is not necessarily the right way to go, but having a smaller model that's more precise and more fine tuning and can be delivered on-prem is another very, very important piece as well. Okay, so these are, understanding the data modality. Again, the whole thing about data is one challenge. The second challenge, right, is about, if you go to any manufacturing clients, they have sometimes tens or hundreds of plants, right? So how can we deploy these models, right, across, let's say, 100 plants, right? It's not only going to just install once, but to have to find a way to somehow deploy this at scale, going from a proof of concept to a full scale deployment is a challenge companies are facing. We see a lot of companies struggling with this part. The other one is, again, the regulatory compliance. They're coming in a big way as well. How we make sure that your models are kind of aligned, right? They are kind of not, overcoming the regulatory compliance to make sure that there's nothing happening in this regard. Is a continuous effort because the regulatory compliance are also evolving as we speak, right? And one more point I think we see a lot is a kind of companies are learning. This becomes a critical knowledge for them, a critical area they have to master, right? And how can they learn and get prepared to fully harvest the full power of GenAI? So internal processes, internal capabilities, etc., needs to be implemented in the company as well. Okay, so those are challenges that we see that are somehow huge opportunity, but the companies need to get it right from the start as well. Okay, and again, we want to avoid, based on our previous experience, avoiding the same mistakes that was made before. You get stuck with the POC not being able to scale. We have all the capabilities we need in order to drive this scalability.
You hear a lot of people talking about the POC graveyard, right?
Exactly, exactly,
Where
exactly. Yeah.
lots
Again,
of
apologies
ideas.
again, but we do have a way to make this happen. I would say in a very solid way as we go forward.
So may I ask? There's all of this opportunity. There are challenges. So how do yourself and your colleagues at IBM? How do you work with companies to handle some of this?
Yeah, we have the benefit of work with many clients around the globe, right? And understand where they are with their thinking, etc. But our approach has been very practical, focus on time to value. You can do a lot of things on this area, but instead of going and spending a lot of time discussing how can we make this as practical as possible for you, our
Hmm.
client, right? And this starts with an understanding of where the client is, more or less. We know that manufacturing clients, they have a lot of systems already in place as well. They have their ambition, the ambition of different stakeholders in the client. Could be ambition of the plant manager, could be one. The ambition of the COO that looks across all the plants could be a little different. So you have to balance very quick wins to a kind of a broader digital transformation. But by working with the client, understanding where they are allows us to create a program for them to drive this at scale as well. Okay. And then, of course, in order to enable this to happen, there's two pieces of the puzzle. One is to leverage on our, technology, right? We're bringing open technology. We call in IBM Watson X platform that would allow us to deal with the complexity of the data. First, understand
Hmm.
the data, understand which data we're going to use to train the models, which data we're going to be using to make decisions, etc. Picking the right models, I would say. And the platform is open in the sense that the customer themselves can create their own model if they want. They can use open source model, right? They can look at the third-party models, etc. It's open. Make sure to have the right model for the task that you're going to be doing, right? One interesting comment is that IBM, we decided to open source our models. We call Granite series of models in such a way that we can collaborate with the overall ecosystem around. Just on the topic of time series, again, that I mentioned before, we have more than 1 million downloads in Hugging Face on this one. This is a very hot topic. We believe we do have a leadership position in the precision, the size of the models, and the ability what we can do there as well. Okay, but again, look at the right models is a part of these things, and then the governance. The governance is another very important point. The deployment at scale, the governance of the models. The models are going to be evolving over time. Are they evolving the right way or not? They're not drifting away, right? Make sure that the regulatory compliances are taken into account, even cybersecurity. So the platform allows the technology platform that you bring to the table allows all these pieces to fit together well. And the second part of the story is the knowledge, right? As I was saying, we have learned a lot over the last 20 years or so, 30 years, on how to do this right. So the knowledge of the domains could be maintenance, could be production, could be quality, etc. Allows us to bring a lot of value to our clients as well. In other words, a combination between a very value-driven approach, very practical value-driven approach, the technology, and the expertise we bring to the table.
Now, you mentioned the expertise. You've worked in so many different industries. You've seen a lot of technologies come over the years. From your own personal point of view, where do you see this headed, or what's your advice to people out there looking at all this?
Yeah. Well, I'm a little biased, I would say. I have been dedicated my full life in doing this, right, over many years. I work with many clients, etc. Right, but I think the key point now, we are, as I was saying before, we are in an inflection point. This can really make or break a given manufacturing client if they don't understand and exploit this technology in a big way, right? So take this seriously. I mean, this is coming. We see a dramatic change in the industries going forward as we speak, right? Because this would be opportunity for the companies really to somehow go to the levels of efficiency, levels of productivity, the quality, etc., that was not possible before. If you're not in this game, you're going to be left aside very quickly. So time to actions is critical, I would say. And of course, we're here to help.
No, as you say, that we've seen all the hype around AI, Gen AI, but this stuff is not going away, right? And as you say, it's
Yeah.
if you're not looking at it and understanding
Yeah.
how it can help, the challenges, how to do it right, not end up in POC graveyard. But But yeah, you need to get a plan. So hey,
Absolutely. Yeah.
interesting times ahead.
Yeah, in that, we're really excited with the opportunities and what we can do. And, it's really, really exciting times.
Hey, good stuff. Thanks very much.
Thank you as well.